There are objects in the cosmos that burn brighter than galaxies, and there are those that leave no trace at all. And then, there are the truly unsettling ones. Objects we can't see, can't hear, and can't touch, but whose existence is carved into space itself by their gravitational pull. In the spiral galaxy M33, better known as Triangulum, a shadow has revealed itself. But not a shadow of light, a shadow of mass. Roughly 2.5 million light-years from Earth, astronomers have detected an anomaly, a point in space devoid of stars, gas, or dust, yet surrounded by stars racing at impossible speeds. A million solar masses locked in a gravitational embrace with nothing, no radiation, no flicker, no clue, and still it pulls. With the weight of a million suns, it tugs on the fabric of space around it. Silent, patient, invisible. What could weigh so much and yet remain unseen? The Triangulum galaxy is often overlooked, overshadowed by its massive neighbor Andromeda and our own Milky Way. But for scientists studying galactic dynamics, its relative calm is precisely why it's so interesting. Unlike many galaxies with chaotic centers or frequent starbursts, Triangulum offers clarity, fewer mergers, less confusion, a clean environment in which anomalies stand out. In one of its outer regions, a star cluster drew attention. At first glance, it was just a collection of stars, nothing extraordinary. But as telescopes tracked their motion over time, something unusual became clear. These stars weren't drifting lazily through space. They were orbiting rapidly, almost as if being slung around an anchor that no one could see. This movement didn't just suggest the presence of mass, it screamed it. And not just any mass, something enormous, something concentrated. The kind of gravitational influence typically reserved for the hearts of galaxies or the corpses of stars long gone. To detect something invisible in astronomy is not an act of speculation, it's an act of deduction. Astronomers turn to orbital mechanics, the same physics that governs Earth's satellites and the moon's pull on our tides. By mapping the speed and direction of the stars, they calculated the mass needed to explain their motion. The result, between 800,000 and 1.2 million times the mass of our Sun. But where was it? No luminous object could account for the gravitational influence. There was no bright quasar, no X-ray signal, no supernova remnant. The region was, by all optical and infrared measures, empty. Yet the stars spun faster than the laws of physics should allow, unless something massive and unseen held them in its grip. It was as if gravity had cast a shadow. The first and most obvious explanation, a black hole. But not just any black hole, an intermediate mass black hole, IMBH. Black holes are not new to science. We know stellar mass black holes, born from supernovae, exist by the dozens in our galaxy. And we know supermassive black holes, with millions or billions of solar masses, lurk at the centers of most galaxies. But between these two extremes lies a mysterious gap, a missing class. Intermediate mass black holes are theorized, but almost never seen. Too big to be remnants of single stars, too small to anchor galaxies. Their existence has been a question mark for decades. Now, for the first time, we may be witnessing one in action. If confirmed, this could be the Rosetta Stone of black hole evolution, the missing link in how galaxies grow, how small black holes merge, and how the seeds of cosmic giants form. But there's a problem. Even black holes usually give themselves away. Black holes are invisible, yes, but not silent. When matter falls into them, they roar. They emit X-rays, radio waves, jets of high-energy particles. They devour gas clouds, bend light, and leave fingerprints and radiation across the spectrum. This object does none of that. It is truly quiet, starved, dormant, or something else entirely. Could it be a compact cluster of stellar remnants? Hundreds of neutron stars and small black holes packed together so tightly that they mimic the gravity of a larger object? Or could it be a dark matter concentration, a clump of this still theoretical substance, exerting gravity without light? Each theory has its flaws. Each demands further observation, and none, so far, provide all the answers. We're staring at a gravitational footprint, but we don't know what made it. The search for the invisible demands new tools. In the coming years, the Vera Rubin Observatory will begin its legacy survey of space and time, scanning the entire sky every few nights, building an evolving map of the universe in motion. With it, we'll be able to track proper motion across galaxies, catching unseen gravitational pulls in the act. Gravitational wave observatories like LISA, Laser Interferometer Space Antenna, may someday detect mergers of these invisible giants, even if no light is ever emitted. And theoretical simulations, growing more complex by the day, will help us predict where to look next, what kind of gravitational anomalies to expect, how hidden mass shapes galaxies from the shadows. Because the truth is this: most of the universe is invisible, not just in mystery, but in reality. Dark matter, black holes, vacuum energy, unseen forces dominate our cosmos, and slowly, we are learning how to hear their whispers. If this invisible object is an intermediate mass black hole, it confirms more than just a theory, it maps a pathway. It means black holes don't just grow at galactic centers. They can evolve in isolation. They can sit quietly for billions of years in the dark outskirts, untouched, unnoticed, until a passing star cluster gives them away. It means that galaxy formation may be seeded by invisible forces long before the first stars ever ignite. And it may mean that for every luminous supermassive black hole we know, there are dozens more hiding in plain gravitational sight. Our universe isn't just strange. It's stranger than we thought, stranger than we dared to imagine. And it is telling us, in the quietest of ways, that we've only just begun to hear its secrets. Astronomy has always been about light. Telescopes measure brightness, color, spectra. We see the universe in photons. But this is something else. This is the practice of reading motion, of feeling the pull of an object without ever glimpsing its face. It's a form of cosmic braille, tracing the invisible by the scars it leaves on the visible. With every orbit measured, every acceleration tracked, we reveal more about these giants in the dark. And we realize we are not alone in this galaxy, not just in terms of life, but in terms of mass. The void is not empty. It is crowded, silent, ancient, waiting. 1,000,000 suns, bound into one point. No light, no fire, no shape. But wait, the stars know it's there. They spin, they fall, they obey. And now, so do we. In the darkness between galaxies, an invisible king reigns. And somewhere in the silence, it waits to be seen.